We'll see if that thing's taken off. I've got the recording going, so let's pray. Father, thank you for this time we have together. I ask your blessing on these students as we work through this third topic in chapter 4. Help them to understand the concepts and to take notes that will equip them and prepare them for doing well on the chapter 4 exam. In Jesus' name we pray. Amen. So what's it doing? Didn't connect, huh? Well, let's try it again. Ah, there it is. Again, my apologies to the online people who have to just listen to nothing for a few minutes till we get this thing up and going. We're on page 206. In problems 1 through 4, write numerals in the bases indicated by the manners of grouping. So problem 2 has them grouped in groups of what? 5? So that means we're writing in the base 5. And we have 3 groups of 5. And I know the book shows it differently. It shows a group of 3, but I thought that could be confusing because if I said 3, 3, you might not know which 3 is what. So these 3 make up the 3 groups of 5, and these 4 are 4 ones. Everybody follow that? So, what do we have here? 5, 10, 15, 16, 17, 18, 19. We have 19 little x's. And those 19 x's, 19 is the numeration system we think in normally, base 10. But 19 in base 5 is 3, 4. It's not 34, because 34 is the word we use to express base 10 numeration. It's just 3, 4. It's 3 5s and 4 1s. And 3 5s would be 15, and 4 1s would be 4 more. That would make 19. Everybody follow that? Questions? Then let's do another one. Number 6. It says write each decimal numeral in the given base. So 15 is the decimal numeral, and I'm going to write it in base 5. So watch what I do. When they say base 5, that means I have 5 to the 0, 5 to the 1, 5 to the 2, then the next one would be 5 to the 3, 5 to the 4. You follow how we do with the decimal system? In the decimal system, don't we write for the decimal system? Don't we have 10 to the 0, and then 10 to the 1, and then 10 to the 2nd, and then 10 to the 3rd? And this is the 1's place. This is the 10's place. This is the 100's place. And this is the 1000's place. Isn't that the way you were taught it somewhere in life? And if you weren't taught that, then go ahead and put the decimal system down, because that's our frame of reference. That's the way we do math in our minds and our heads. That's the way we're taught math, with the decimal system. And now we're taking 15 in the decimal system and putting it in base 5. So since the base is 10 for decimal, for base 5 it's 5 to the 0, 5 to the 1, and 5 squared. And of course 5 squared would be the 25's place. So instead of 1s, 10s, 100s, 1000s, we go 1s, 5s, and 25s. You follow where those words come from and how we get that? So 15 would have, I just put them over here. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And you could circle each one of those as a group of 5. And that means there are 3 5s and no 1s. So the answer is 3, 0 in the base 5 for translating 15 into base 5. So what's going to happen is every time they give you a question, like for example, when you're doing problem 5, let's just scroll over here. When you do problem 5, it says 15 in base 8. So when it says base 8, you're going to write down 8 to the 0. Everybody see that? And then 8 to the 1. And 8 to the 2. And what would that be? This is 1s. This is 8s. And what's 8 squared? What's 8 times 8? So this is 64s. So I don't have any 64s in 15, do I? So do I have any 8s in 15? 1 8 in 15. So I subtract 8 from 15, and what am I left with? 7. So what goes in the 1's place? 7. So for problem 5, the answer is 1 7 in the base 8. Everybody see how that works? Good. And this is the way you show your work for this stuff. You show your work by making these place values, and I put little boxes under them that I'm filling them in. So when I say show your work for this stuff, that's the way you show your work for problems 5 and 7. Then of course problem 7 says use base 7. Now some people have asked me in the past, is it okay if I just make a base 8 and put that on a piece of paper and then make base 7 and put that on a piece of paper so I don't have to keep making it up all over again every time? And the answer is sure. You can just have a sheet of paper with a whole bunch of different bases on it, then you can look back at it as a reference for when you're doing the work. So now we're back over here to number 8. 15 in the base 12. So what's base 12? 1s, 12s, and 144s. What's going on here? Are there any 12s in 15? There's one 12, isn't there? One group of 12. When I take out 12, I'm left with 3. Everybody follow that? So it's one group of 12 and 3 1s, which would be 1 3 in the base 12. And over here to the right, I've written the numerals for base 12. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And then after 9 would be 10 and 11. But you see how difficult that would be if you had 2 digits for one place? So for the base 12, or the duodecimal they call it, it has a number of different names. For base 12, there are 2 ways to talk about it. Some people say 10 is T and 11 is E. See where they get that from, 10 and 11? But other books, some books will talk about 10 is A and 11 is B. And the only reason I prefer the old TE method is because when we come down here and study base 16, we're going to use A for 10 and B for 11 and C for 12 and D for 13, use letters clear up to 15. And I have found in the past that some people think, well, A and B are used for base 16. Why are you using A and B for base 12? So I think that's why, and if you go to the internet, it'll say you can do it either way, but most modern day mathematicians just use A and B because they understand that they're working with base 12. But when you're first learning this, I think it helps to have T for 10 and E for 11 when you're doing base 12 stuff. Just trying to be helpful in terms of you wrapping your mind around this stuff. Okay. Any questions? You see how to do the homework? Number 10. Write each numeral in decimal notation. Number 10 says 3, 1 in the base 5. Now what is that? That's the ones place. That's the fives place because the base is 5. Everybody follow that? So that means I have 3 5s and 1 1. What's 3 times 5? 15 plus 1. So the answer is 16. Does that make sense? Number 12. 5, 6, 3 in the base 8. So if the base is 8, I'm going to have 8 to the 0, 8 to the 1, 8 to the 2. And what would that be? This is the ones place. This is the eights place. And what's 8 squared? This is the 64's place. Okay. So I have 5 times 64. You see that? Plus 6 times 8 plus 3 times 1. What's 5 times 64? 320. Plus, what's 6 times 8? 48. Plus 3. What's that come out to equal? 368, and 3 is 371. And you say, well, how do we know what base it is if nothing's written there? Then it's understood that it's base 10. But since we're thinking in bases now, if you want to write a 10 down there, you're welcome to do that. It just isn't necessary because it's understood that we're talking about base 10. But once we start talking about different bases, sometimes you say, now that I'm thinking bases, I'm going to put a 10 down there so I know I'm talking about 371. Any questions about 12? What about 14? 101001. And the base is 2. So I have 2 to the 0, which is the 1's place, 2 to the 1, which is the 2's place, then 2 squared, 4's place, then 8's, then 16's, then 32's. You follow me? And what do I have? I have 1, 32. Everybody see where that comes from? I have no 16s. I have 1, 8, no 4s, no 2s, and 1, 1. So what's 32 and 8 and 1 add up to? 41. So 101001 in base 2 or binary is 41 in decimal. You got it? This is so much fun. how many places do we have here? 1, 2, 3, 4, 5, 6. You can take 6 big index cards. Those of you who want to mess with little kids' heads, you can take 6 big index cards and put on those cards all the binary numbers from 1 to 32. Then you can ask a little kid to pick a number between 1 and 32. Then you hold up the cards and you say, is your number on this card? And if he says yes, like if his number was 41 and I held up the cards, okay, 32 would be on the first card, and I'd say, he said, yes, it's on there. So I go 32 in my head. I said, is it on the next card, which is the 16th place? And he says, no. So I skip it. I say, is it on this card? And that's the 8th place. He says, yes. So I add 8 to 32 and get 40. I said, what about this card? He says, no. What about this card? He says, no. What about the last card? He says, yes. So I add 1. I say, your number's 41. He goes, how did you do that? And all you do is just make up a set of flashcards with all the numbers that include that place in them. Because it's either yes or no, 1 or 0. So you can, when he says yes or no, he's telling you whether he's got a 1 in that place. Because with binary, you only have 2 numerals, 0 and 1. And if you go, what was that again? I think you can go on the internet and find that little pick a number between 1 and 32 kind of exercise, and it'll show you how to make the cards. Just for fun, if you want to mess with little kids' heads. Or sometimes grown-ups too. Number 16. Have you ever seen a number like that before? A, C, E. You have now. And here are the base 16 numerals. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Oh, I left one off. How come I did that? I don't know. F is 15. A, B, C, D, E, F. So, this first one is 16 to the 0. That's the ones place. This is the 16's place. And this one is 16 times 16. What's 16 times 16? You have a calculator? What is it? So this is the 200, is that right?
Yeah.
This is the 256th place. So now watch. What does the letter A stand for? 10. What's the letter B or C stand for? 12. And what's the letter E stand for? 14. So I come down here and I go 10 times 256, that's 2,560, plus 12C, 12 times 16, that's 192, plus 14 times 1. And what does that add up to? You don't want to tell me. 2,766. There you go. What do you think? You feel powerful? All your life, you thought there was only one base you could think in, and now you've learned you have a whole bunch of others you can mess with. Number 18. In problems 17 through 32, and we stop when you get to 31. So there'll be plenty of time after class today to answer questions, and for those who want to correct their test, we'll be around to do that too. Now, it says in the instructions, use the method of successive divisions And do you have written in your book, or use place value charts? If you bought your book from someone who had this class before, there should be an or use place value charts. You can do it either way. I'm not going to restrict you. In other words, I've been using place value charts to teach you what this stuff means. So if you want to keep using place value charts, you're welcome to do that. If you want to use the division method, the successive division method, I'll show you that one too. Okay, let's do the place values. Base 5 and 27. 27 in the base 5. This is 5 to the 0, 5 to the 1, 5 squared, 5 to the third, which would be the 1's place, the 5's place, the 25's place, and the 125's place. Well, there's no 125's in 27, are there? So I just go to the 25's. And there's how many 25's in 27? So I put a 1 in here, then I subtract 25. See that? And that leaves me with what? Once I take 25 out, that leaves me with 2. So how many 5's in 2? 0 5's. And then how many 1's in 2? 2 1's. So the answer is 1, 0, 2 in the base 5. That's what 27 is equal to in the base 5. Now, let me show you the way they do it on, what page is that? 204. They take 27 and divide by 5. And what do you get? 5 times what is less than 27? 5. Let me change this to red. 5 times 5 is less than 27 with a remainder of what? 2. Then I take this and divide by 5, and I get 1 with a remainder of what? 0. Then I take this and divide by 5, and I get 0 with a remainder of what? 1. So what's the answer? 1, 0, 2. Start from the bottom and read up. 1, 0, 2. Now I think in the book, I'll change to green. In the book, they don't put this last step in here. They have you go like 1, 0, 2. They just have you read up like that. But it seems to me like if you're trying to get this thing in your head as to a way to do it, it makes sense to keep dividing till you have 0 left. And then you just read right up the left-hand column to get the number. So my successive division picture will look a little different than the one does in the book. I'm just adding an extra step that the guy who wrote the book would say, you don't really need it. And I would say, you don't need it, and I don't need it, but I have a room full of people who do because they're trying to make sense out of this stuff for the first time. Okay? Any questions? Number 20. (43) in binary. So I go 2 to the 0, 2 to the 1, 2 to the 2, 2 to the 3, 2 to the 4, 2 to the 5, 2 to the 6. And of course, 2 to the 0 is 1, 2 to the 1 is 2, 2 squared is 4, 2 to the third is 2 times 2 times 2, 8, 2 to the fourth is 2 times 2, 4 times 2, 8 times 2, 4 times 16, 2 to the fifth is 32, and 2 to the sixth is 64. You go, I don't need 64 because I'm only looking at 43. You follow me? So I put my boxes down here. And I put 132, so I subtract 32, and I get 11. Oh, well that means there's no 16s And then how many 8s? 1. Subtract 8. And what am I left with? 3. So that means there's no 4s. And 3 would have 1, 2. Subtract 2. Now I'm left with 1. And 1, 1. So the numeral would be 1, 0, 1, 0, 1, 1 in the base 2 is 43 in the decimal notation. You like that? You go, no? I want to use this successive division thing. Okay, let's do it. We take 43 and divide by 2, and we get 21. Agreed? With a remainder of 1. 2 times 21 is 42. 2 into 43 is 21 with a remainder of 1. Then 2 into 21 is 10 with a remainder of 1. Then 2 into 10 is 5 with a remainder of 0. Then 2 into 5 is what? 2 with a remainder of 1. And then 2 into 2 is 0. No, I'm sorry, is 1 with a remainder of 0. And then 2 into 1 is 0 with a remainder of 1. See why I'm doing that last step? So read it up like that. And what's the answer? 1, 0, 1, 0, 1, 1 in the base 2. Do those two answers look like they match? So you can pick your method if you want. You decide which way works best for you in terms of doing the homework, because you got a whole bunch of problems to work. Number 22. 121 in hexadecimal. Did you know that hexadecimal is base 16? Duodecimal is base 12. Hexadecimal is base 16. Octal is base 8. You probably ought to put that in your notes somewhere, because you're probably not going to remember it otherwise. So I go 16 to the 0, 16 to the 1, 16 squared. And what's 16 to the 0? 1. What's 16 to the 1? 16. What's 16 squared? 256. Isn't it? See why if you make the chart once, you can just keep looking back at your chart and saying, where's my place values for base 16? And 121 is the number I'm working on, so I don't need to go up to 256. But how many 16s in 121?
7.
And if I take 7 times 16, what do I get? 112? So I subtract 112 from, now you say, how did she come up with 7? Well, okay, try 6. What's 6 times 16? 96? 96 would leave too much for the next place. You follow me? In other words, 96 is too small. 6 is too small. 8 is too large. What's 8 times 16? 128. That's more than my number. So you see how you kind of do a little fishing around to find it there? Then you say 7 times 16 is 112. Subtract 112, you're left with 9. So that's 7 16s and 9 1s. Or it's just written 7 9 in the base 16. And don't say 79, because 79 is the label. Those are the words we use for base 10 stuff. Let's do it with successive division. Take your calculator and divide 121 by 16. And what do you get? 7 point something? Is that right? What'd you get when you divided 121 by 16?
7.56.
7.56. So I put 7 in here, okay? And now, see, 7.56, I don't want that decimal. What's 7 times 16? Punch in 7 times 16. What do you get? 121? No, 112. 112. So 7 times 16 is 112. So what's my remainder? 9. Everybody follow that? Then I come down here and take 7 and divide by 16. And I get 0. And what's my remainder? 7. So the answer is 7, 9 in the base 16. There you go. Now, granted, because we've already done it this way, that's kind of giving you kind of a clue as to where you're going with your successive division thing. But maybe I should scroll one over and do successive division first. Let's do that on the next one. Let's just move this over where you can't see that part. So which one is this? 24. 38 into base 6. So I put down 38 divided by 6. What's 6 times 6? 36 with 2 remainder. Everybody see that? Then I take 6 and divide by 6. And what is that? That's 1 with no remainder. Then I take 1 and divide by 6. And that's 0 with 1 remainder. So what's my answer? 1, 0, 2 in the base 6. See what's going on? Now let's go back and do it the other way. Base 6. 6 to the 0, 6 to the 1, 6 to the 2, 6 to the 3. So here I am with 36, and I have one of those. So I subtract 36 from 38, and I'm left with 2. And how many 6's in 2? None. So I put a 0 in that box, and that leaves me with how many 1's? 2. So the answer is 1, 0, 2 in the base 6. So have we done enough of these for you to decide whether you want to do successive division or whether you want to make a place value chart? They both work. It's just a matter of what's your preference. And I don't know why the textbook said use successive division, unless they're just thinking that most people just want a quick mathematical algorithm that they can use to find an answer without thinking about what they're doing. I prefer to help people develop their mathematical thinking abilities because it's so much more fun. Well, I don't see a lot of smiles out there. So maybe 2 or 3 of you are having fun and the rest of you are going, this TIS. 26. 26 says, write the number 123 in the base 7. So now I'm going to make 7 to the 0, 7 to the 1, 7 squared, 7 cubed, 7 to the 4th. And that's 1, 7, 49, 1s, 7s, 49s, and 343s. Well, I don't use 343s, but how many 49s are there in 123? 2. 2 times 49 is 98. So I put 2 in this box and subtract 98 from 123, and I'm left with 25. So what do I do with 25? How many 7s in 25? 3. So I take 3 times 7 is 21, subtract it, and I'm left with 4. So that's 4 1s. So the answer is 2, 3, 4 in the base 7. If we do it with successive divisions, 123 divided by 7 is 17 with a remainder of 4. Do some of you have a calculator that will do remainders? There are calculators out there that'll do that for you. They just cost more money. And then I take 17, divide by 7, and I get 2. 2 sevens is 14 with a remainder of 3. Then I take 2 and divide by 7, and I get 0 with a remainder of 2. So what's the answer? Remember, you're reading up. 2, 3, 4 in the base 7. What do you think? Are we on our way? Number 28. 135 in octal. Octal is base 8. Just put that down in your notes. Octal is base 8. So I have 8 to the 0, 8 to the 1, 8 squared, 8 to the third. And how many 64s in 135? 2. And that gives me 128. So 135 minus 128 is what? 7? How many 8s in 7? 0. So how many 1s? 7. So when I come over here and take 135, divide by 8, I get 16 with a remainder of 7. Now with your calculator, you're probably going to have to do it twice. You'll take 138 and then hit divide by 8, and then what do you get for an answer? 16 point what? See, it doesn't matter what you get after the decimal point. You put the 16 down there, and then you go back and take 16 times 8, and what do you get for an answer? 128. Then you subtract the 128 from 135, and you get 7 for your remainder. You follow where you're doing it twice with your calculator? Sometimes you can do it in your head, and sometimes you have to work it out on paper. So the answer is reading up 207 in the base 8. Number 30. Whoa. 145,263 in the base 16. Well, base 16 is 16 to the 0, 16 to the 1, 16 squared, 16 to the third, 16 to the fourth is the 65,500 place value. Those are place values. So I end up with, if I take 65,536 times 2, what do I get? 131,072. And I subtract that from 145,263, and I get 14,171. How many 4,000s in 14,000? 3. So I take 3 times 4,096, and I get 12,288. You with me? Then I subtract that from 14,000, and I end up with 1,903. And I divide that by 16, or how many 16s in 1,903? Oh, I'm sorry. 256s. Don't skip those. How many 256s? And see, what you can do with your calculator, you can take 256 times 5, and then 256 times 6, and then 256 times 7, 256 times 8. You just go use the trial and error method. You go, well, 8's too much, so it'll have to go back to 7. And then 7 times 256 is 1,792. And that leaves me with 111, which is smaller than 256, but it's larger than 16. So now how many 16s in 111? 7 would be 100 and what? 14? 112. Yeah, 7 16s would be 112. That's too much. So I back up to 6 16s and I get 96. And then I subtract 96 and I end up with 15. So how do I say 15 in base 16? Where did I put my little chart up here? Where did I put that up here? There it is, base 16 numerals. 15 is the letter F. Everybody see that? So I go down here. And put an F in this little box. To represent 15. So you'll have to put those base 16 numerals, A, B, C, D, E, F in there. So you'll know when you've got something like 15, that 15 is F in the base 16 method. Now, again, if you use successive division, you divide 145,000 by 16, and you get 9,078 point something. So you take 9078 times 16, and you find that you subtract that from 145,263, you get a remainder of 15, which is called F. Then you divide that by 16, and you get 567 point something. You take 567 times 16, subtract it from 9,078, you get a remainder of 6. Everybody see what's going on? Moving too fast? Just about right. Divide this number by 16, and you get 35 with a remainder of 7. Divide 35 by 16, you get 2 with a remainder of 3. Divide that by 16, you get 0 with a remainder of 2, and your answer is red going uphill. 2, 3, is that what we got before? Yeah, oh, there it is. 2, 3, 7, 6, F in the base 16. Oh, I had it down below and didn't scroll down there to see it. How sad is that? Number 32. The last one. 87 in octal and hexadecimal. So they want me doing both base 8 and base 16. So I put down my place values for base 8. 1864. And then I put 164. Subtract that, and I'm left with 23. How many 8s in 23? 2. And subtract 16. 2 times 8. And I'm left with 7. So I just put 7 in here. 7 ones. 1, 2, 7 in the base 8. Then in base 16, I would have the ones place, the 16s place, and the 256 place. 16 is all I need, and I have how many 16s in 87? 5. 5 times 16 is what? 80? And that leaves me with 7. So it's just 5, 7 in the base 16. That's hard to read. Let me take that out there and just make it black. 5, 7. Okay. That's it. Stop when you get to 31. Now, since we only have one lesson on this, I think, don't we? 4.4 has you. Okay, 4.4 says, now, when we get to 4.4, we're going to learn how to add, subtract, multiply, divide in binary. We could learn how to add, subtract, and multiply and divide in all of these, but the only one the book wants you to learn is binary, so that's the one we'll stick with. So, this is the only lesson we have on this, so you want to have good notes when it comes time for the test, or you'll just be guessing, and we all know how that works, don't we? All right. Well, that's it. If you want to correct your test, or if you have some questions on past homework, I'll be around here for a while to help you.
I was hoping for Thank you.
Those of you who are in the play, don't worry about trying to turn your homework in right away. You need time to do that kind of stuff.
Yeah, I got this one.
Good day.
That's okay?
It was almost 5 hours.
Yep, you can turn it in. You can turn it in another day.